This video demonstrates how to perform a primary grid scan followed by a secondary grid scan using the AnyCat remote interface. A grid scan collects a sequence of images from a grid of spots arranged across a two-dimensional area. The grid scan is most often used to locate crystals in mounting loops when the crystals are not easily visualized. A primary grid scan is often a widespread search of the entire loop in order to identify either the position of the crystal or regions of interest to be investigated more closely. A secondary scan is utilized especially when dealing with small crystals in large loops. In those instances, it is much quicker to scan the large loop with the largest aperture available, identify potential regions of interest, and then perform secondary scans on those regions with a smaller grid utilizing a smaller aperture in order to more precisely locate potential crystals. A grid scan should not be performed at zoom 1. Ensure that your zoom setting is above zoom level 1 before proceeding. In order to perform a grid scan, the user must create a vector along the loop to define the horizontal extent of the grid to be scanned. Ensure that the crystal loop is oriented such that the broadest portion of the loop is presented to the camera in the sample view. Then, using 3-click centering, center on one edge of the loop. Save that position, then center on the opposite edge of the loop. And save that position. The recorded vector is displayed as a green arrow with the endpoints indicated by the X's. If you are not satisfied with the position of the vector, you may clear by pressing clear and reestablish the vector again using 3-click centering and saving the ends of the vector. The vector should not be too vertical. A horizontal vector is most efficient, and a vector that is too vertical may cause a math error that freezes the beamline software. To proceed, go to the Scan tab and select the grid among the select tools. The first scan performed on a sample is always a primary grid scan. The primary grid scan may be run in 3 different modes: fill, loop, or hybrid. Loop is default and is the most common method of performing a grid scan. With loop, image analysis software is used to identify the extent of the loop, and the software then fills the region defined as loop with a grid of spots. Fill mode requires the user to use the left mouse button to click and drag out a rectangle in the sample view, and then the entire rectangle will be filled with a grid of points to be scanned. This mode is most often used when the user wants to scan only a small portion of the loop that is entirely inside the boundaries of that loop. Hybrid mode also requires the user to click and drag a rectangle. In this case, the grid points will be defined by the area inside both the rectangle and the loop. So areas outside of the loop but still inside the rectangle will not be collected. This mode is useful when the user wishes to scan only a portion of the loop. For our demonstration, we will use the loop mode. For a primary grid scan, especially with larger loops, it is recommended to use the largest aperture size available at the beamline. If you have a large loop, using a smaller aperture will slow down the pace of scanning significantly due to the increased number of grid points that will be generated for the scan, and it is much more efficient to perform a primary scan with the large aperture and then investigate any regions of interest with a secondary scan utilizing a smaller aperture and a smaller area to search. For this demonstration, we will use the 70 micron aperture. The default overlap of 20% ensures no gaps between grid points while not overpopulating the number of grid points searched. Consideration should be given before adjusting the overlap from its default value. The distance defaults to the current detector distance. If you have already established that distance for your use in snapshots, keeping the detector distance at that value will increase efficiency as it eliminates the delay caused by moving the detector. If you have not established a distance yet, 500 millimeters to 600 millimeters is a good distance to set the scan to. Although you want to keep transmission as low as possible, if you have weakly diffracting crystals or are using the smallest aperture, you may need to increase the transmission above 10%. Once you have set the scan parameters to your desired values, press Define Scan. The beamline will take a moment to initialize the scan. Once the scan is initialized, you will see red circles representing the grid points that will be scanned during the grid scan. And you will be presented with the options to go, modify, or abandon. Abandon tells the beamline that you do not wish to perform this scan, and the beamline will exit out of the grid scan protocol. Modify lets you adjust any of the scan parameters and then reinitialize the scan with the Define Primary Scan button as before. Go tells the beamline to execute the grid scan with the current parameters. If you are ready to proceed, press Go. Once you press Go, the scan is initiated and you will see a progress bar indicating that the scan is running. As the scan runs, each frame of the scan is analyzed by the peak picking software Distal, and results from Distal are presented below the main viewing screen in a table and has a bar graph. Clicking a line in the table will bring up a view of that specific frame cropped down to the central portion of the detector. For a macromolecule, if there is any diffraction at all, it should be visible at the low resolution represented in this view, and therefore this view is suitable for analyzing the results of the scan. Similarly, clicking a bar in the bar graph will bring up the corresponding image. Additionally, in the sample view, the grid points are color-coded with dark green indicating higher scores based on the distal metrics, while red indicates lower scores. Clicking any position in the view screen will bring up the corresponding frame for that spot. The default is to rank the distal results by good spots. These are spots identified based on criteria that would make them suitable for indexing the lattice of the crystal. Search through your results and find a position that you're interested in, and then press Move to Selection to have the beamline move to that point. At this point, you may either return to Data Collection tab in order to collect a snapshot or run at this position. Select Data View None, and then perform a vertical scan in order to center this position in the orthogonal view. Or you can use the results to pull up a secondary scan. So here I've reselected the scan that I just performed, selected my position of interest, and requested it to move to that selection. Now in the upper left I have the option of secondary. Clicking on secondary brings up the secondary scan setup. Typically, the zoom will default to a value higher than what you're initially at, allowing you to zoom in closer and get a more detailed view. It is recommended to use a smaller aperture for the secondary scan than the primary scan. The middle value of either 20 microns or 30 microns, depending on which beamline you're at, is generally suitable for the secondary scan, although if you have extremely small crystals, you may want to select the smallest aperture for that beamline. For this demonstration, we'll use the 30 micron aperture. Overlap is increased to 30% in order to provide a more precise and detailed sampling of the grid. Detector distance again is kept the same as what was used for the primary scan and should not be adjusted in order to increase efficiency. Transmission should be increased since we are using a smaller aperture than before. Generally, for the mid-size apertures, a transmission of 15 to 20% is appropriate. If using the smallest apertures, a transmission of 25 to 30% is more appropriate. Although with weakly diffracting crystals, you may need to increase further. Note that because the scan results search for spots at low to moderate resolution, it is common that you can scan successfully with a transmission below what you would use when trying to get the highest resolution diffraction possible from your crystal. So if in doubt, tend towards lower transmission and adjust higher as needed. When you are satisfied with the scan parameters, press Define Secondary Scan to initialize the secondary scan. Once the scan is initialized, it will request you to select an area to scan. If this select area window is in the way, simply left-click in the gray area at the top of the window and drag to move the window out of the way. In order to select the area to scan, you will click and drag out a rectangle using the left mouse button over the region of interest. This should generally be around the center position of the screen, since that is the area that you have selected as your region of interest. Simply left-click and drag out a rectangle. This will define the extent of the secondary scan. If you are not satisfied with the initial position of the rectangle, simply click and drag out a new one. Once you have the rectangle positioned as desired, press Done. This will initiate the scan further and then present you with the view of the scan points as before, as well as the options to go, modify, and abandon. If you are satisfied with the position of the grid points, press Go. Again, you will get the scan progress bar indicating that the scan has been initiated, and as results are collected, they will be analyzed by distal and presented in the table and bar graph below. Analyze your results to find the position you wish to move to. Once you have selected that position, press Move to Selection to tell the beamline to move the crystal to that position. To return to a live view, either return to the Collection Scan tab or under Select Data, select None. The crystal will be centered at the point that you selected. If you want to conduct another secondary scan at a different point of interest, simply reselect the primary scan from the Select Data menu. Choose another spot to move to, and move to that selection. Then you can select Secondary again and set up a secondary scan as before. Results from scans that have already been collected during your session may be viewed on the Scan Select Data tool menu. The scans are named using the convention of the puck name, in this case NE_10, has entered into the remote database, followed by the number indicating the position of the crystal within that puck. In this case, we've mounted position 7, and so the scan is called NE_10_7. The final number indicates which primary scan or other scan has been conducted on this sample. In this case, this is the second scan done on this sample. Within a primary scan, you may also pull up the results of the secondary scan from the secondary scan menu. As long as you have not dismounted the current crystal, you can use these results to select a new position to move to. Whether performing just a primary scan or a secondary grid scan, it is often useful to follow up with a vertical scan conducted at 90 degrees from the current orientation of omega. Please see the vertical line scan tutorial on the AnyCat website for more information. This concludes the demonstration of the grid scan as performed through AnyCat's remote interface.